Hey, welcome back to the Build It Basement. Today we're going to be putting our angry idlers on our printer. It's going to be a quick video, so we're also going to go in and talk a little bit about our print bed and prep our Mandala print bed to put on the printer. Then the LDO kit comes with everything already assembled, meaning the heater's already assembled and on the actual heating bed. However, with the Mandala that I bought, it is not. So we're going to attach that. We're going to prep the bed, get that attached, and do those idlers first. So without any further ado, let's go. So one quick thing I wanted to add before we move too far into this, I want to give a shout out to Rick. Rick mentioned a couple of things that I missed, namely on the LDO literature, the DIN rails on the bottom, which I'm going to modify right now. They call out that they want them running in the same direction, which is not what the standard Voron manual calls for. So we're going to swap those around real quick. I think there was something else. I don't remember what it was. But anyways, let's get that done. So kind of going backwards a little bit here, but this will be really quick. And again, these right now are going across from the extrusions that we're going to mount our bed from. They're like this. These are opposite of them. They're going to be lining them up in the same direction if you're using the LDO kit. I do have reservations on that, and they're kind of subsided by the fact that I bought the aluminum backer plates from KB-3D. So this will not sag, but you would if you were using standard plastic for your bottom. Need to put, they make these little clip things, little clips. That'll help you out with that, but I'd still be a little bit worried about it actually working out right. Another thing I forgot to put on, and it's just because I couldn't find them, but the little covers that they make for these things. So little DIN rail cover ups at the ends, and these are strictly cosmetic, but we'll get them on there, make everything nice. So if you catch me doing anything wrong or see anything that you wonder why I did it a certain way, feel free to go ahead and leave a comment down below. I'll go ahead and give you a shout out in the next video if it's something that I need to fix or change. This one was something that I didn't necessarily have to do, but might save us some headaches down the road when it comes to actually mounting the electronics to this thing. LDO has a very specific layout that they want you to do, and part of that layout and part of that has to do with the length of the cabling they give you, because do remember that everything on this kit, for better or worse, is pre-crimped, ready to install. One of the negatives to having everything ready to install is you have to do it exactly the way they want you to, or else what? Or else it won't fit. If it don't fit, you gotta make it from scratch, or you gotta quit. One, two, right? All right, so we got that one, this one swapped over too. And kind of a silly note on DIN rails, just in case you're not familiar. DIN rails face so that the flat surface is back towards and the lips are facing out, because DIN rails are basically mounting hardware, and these lips are what things are going to mount to. So another side note right there. All right. Again, Rick, thank you for pointing this out. I think I could have left it the other way possibly, but I didn't want to struggle with the electronics, so why start now? Cool. All right, so idlers. Get this guy off the table for a moment. Table, bench, whatever you got. We've got a bunch of parts. And we got some angry idlers. So for parts, basically we have our printed parts, our top section, our bottom sections that made up to each other. We have idler, or the idlers going into the idlers. T3 nuts, M3x16s, socket head screw, butt head screw on the side, M5x30 go across. That's actually going to be the post that the idler is actually on. So these are really, really, really simple. So let's do them quick. All right, let's see if we get this camera just where we need it. There we go. All right. So for what it's worth, I've upgraded all the cameras to 4K. I'm recording in 4K now. So hopefully things look a little bit better, right? If they do, leave me a comment, subscribe, all that good stuff, right? So these guys, they're two different types. There's a lefty and a righty. They look like that. You get the eyebrows. So basically two piece. This piece actually moves up and down. This is actually your tensioning mechanism. And assembled, they look something like that. So first things first, we need to put our M3 nuts in the top of these guys. Try not to lose any. We need 4, we got 4. And these should fit right in, like that. It might take a little bit of a push, but if you're properly tuned and you've done your test prints and everything's good. That one's a little tighter for some reason. There you go. They should go in pretty easily. So, like that. All right, so these are now twice as many screws as we need here. These are now going to get attached to the secondary piece. Oop, like this. So nut up, screw hole down. This is our M3x16. And we actually just want to get a couple threads in. This should move. See, like that? Should be able to get about 5 to 10 millimeters out of that, give or take. So that's number 1. Number 2. In actuality, you know what, now that I'm thinking about this, you do want to tighten these up at first. And the reason for it, I didn't think of this at first, but tighten them all the way up till they get just tight. What that's going to do is pull your nut down. Should have mentioned that. Better off do it now than later. And then we're going to loosen it back up. There we go. Here we have our movement again. Start back to the first one, do that. You can do that when you get them on the printer, but might as well do it now. And I might as well make mention of it. There we go. And second to last, it's tight, loosen it back up. Last, but definitely not least, Mr. Z3. Okay, so 1, 2, 3, 4. Those guys are like that. Get back to this real quick. So the next thing I want us to do is go ahead and get our pulleys, or our, sorry, idlers. Yeah, those are bearings. Those are idlers. 9mm wire, 2G2 22 or 2GT. Sorry, 5mm. Yeah. All right. So we're gonna need all 4 of these, one for each. We're gonna need our M5x30s. Again, 5 of these, 4 of these. And I'm actually going to grab another 8. Okay. So a total of 12 M5x30s. Eight of them are going to be for attachment. 4 of them are for the idlers. So basically, these are plastic into plastic, so you want to be relatively careful. You don't want to overdo it. And just for neatness, the head of the screw is going on the opposite side of where this little this additional pieces. This is actually going to feed into the extrusion, so this will allow you to undo this if you need to for some reason. So that should turn in pretty easily, and we should get just so we start to see a thread coming through right on the inside there. Yep. And then get our idler, put it in there, and continue to turn this through. It should ride right through to the other side. Again, this is into plastic. The only real amount that you want to tighten that up is just enough so that it gets into the plastic on the other side. Should almost or just about be flush. Should be pretty close. Idler should have a little bit of wiggle room, but not a lot. So there's number 1. Getting jiggy with it. All right, so idler number 2. Strongly suggest you do not use any power tools when building these. Actually, in any part where you have a screw going into plastic, the only real reason that screw is going in is just because it's holding. It's not actually holding anything together, but it may have a lateral force on it. So it's just being used more of a pin than anything else, but as opposed to having a pin and dealing with, you know, that pin sliding out or coming up with some type of mechanism to hold that pin. It's been found to just be easier to use a screw. Some people will argue that the threads on the screw may make noise. And when I say noise, I mean you might have layer issues or other anomalies on your prints. But for the most part, and specifically for the folks that are on the Voron team, they don't agree. So there, little miniature army of idlers. Almost looks like a Nintendo thing. Anyways, all right. So set those aside, back to the PDF. And they want us to put them on there. Go figure. Let's get that printer. All right, let's see. This guy, yep, there he is. So this is the front left of the printer, front right of the printer on the other side over here. So we're going to start off with that. This idler. That's Snuffle Bunny, by the way. My daughter left him down. His name's Mr. Snuffle. This is going to wind up being right here. And what we're going to need is a couple of M5 roll nuts or T-nuts. And we'll get that one in and this one in. There we go. We'll kind of line this up. I thought we were lined up. Maybe we're not. There we go. Make it loose. I'm gonna keep it looser. Slide over. This is gonna be right in the corner, so we want that to be nice and tight to the corner. So we'll hold it in like this. I'm gonna get a little bit on this side. Like that. And then we're gonna tighten this down just a little bit. If I get the right tool. Don't need to over tighten these. Again, we're just in the plastic. That should be good. You know what? I'm gonna go ahead, and it doesn't call for it anywhere. And I've never, actually on my other V2.4, I didn't do this, but I'm gonna throw some thread locker on these guys because they really shouldn't move, and there isn't much service to do on these. So put a little dab on there. All right. Hold that nice and tight in there. Just give it a little tweak. Nothing too heavy-handed. Again, we're going from plastic into metal, so. And actually, that is too tight because they're not moving. So that's how you can tell if you have these too tight or not, whether or not they move. There we go. Tight enough so it doesn't, the priming piece doesn't move, but loose enough so that our adjustment can be made. And those will move when we need them to. All right. So we're gonna do L1 now. That was L0. And that's gonna be very similar. It's gonna go in like that. Couple more M5x30s. You know, it would be fun if somebody made these in stainless but had a black center. You can only have so much fun when you make one of these printers though, right? Oh, I did it again. Ooh, a thread locker on there. Some people say a thread locker will destroy plastic. I haven't noticed that, and it may have some effect on plastic, but I think if it does, they're going to be very minimal. And just your environment has an effect on plastic. All right, so that's all Z1. So let's go to Z2. There we go. Let's see if those are too tight or not. Oh, that's good. Perfect. All right, last but not least, Z3. One I can actually see while I'm working on it. So building a Voron printer is a little bit of a challenge. I mean, it's not horrible. More fun than hard. But trying to videotape yourself making or putting together a Voron is a little bit more challenging. Especially if you're trying to get people a half decent view of the process. Might be a little bit too tight. There we go. Nice. Perfect. All that good stuff. right. So 3, 2, 1, 0. And what's next? So we got all of our Z idlers on here now. Should be good. Probably one of the easiest parts of the build. And let's get down the PDF. Instructions here. Idler orientation, idler face, so basically face it so it's facing out, the eyes on the idler, the angry facial expression should be facing outwards or inwards towards the inside of the printer. The load tabs, like I showed you earlier, should be facing into the extrusion, helps lock them into place. Firmly in the corner. Yes, all that. And all that again. And that is that on that. So now they want us to work on the print bed. And we're going to kind of step sideways here a little bit. I'm going to take our printer down and slide over some stuff. So I think just about anybody that's ever built a Voron 2.4 will agree that this is not a good time to put the bed on, because the bed is the heaviest part of the printer. Let me get the overhead here. So LDO sends over with this kit your print bed with a Kinovo mains 120 volt 600 watt heating pad already attached to it. This has 3M adhesive on it, and then they've gone ahead and they've put some RTV high temp silicone on here on the edges to make sure the edges don't peel up. What you'll also see on this, if you look, is a thermistor right here that is basically measuring temperature from the center of the bed, and your thermal fuse right here. And if you're wondering, this would be your main lead, your positive lead, and this right here would be a return back in, because in AC it's just one big circuit. There's not really a positive and negative, but if you, this would be power coming in, power going out. So if this thermistor breaks, you don't have power still running inside of this and just not returning. So this is no longer energized. This right here would be your screw for your grounding of your bed. So that's that pretty quick. So we're not using the bed that came with our LDO kit, because I bought a upgrade for that. I will say that this bed looks very good. I don't see anything wrong with it whatsoever. I don't have any precision measuring tools to tell you how well it's machined or anything like that. But I can tell you that it does look like it's been ground. I can see markings on it. So I can only make an assumption that this is to a certain level of flatness that is probably well acceptable. That's what I got. So we're gonna set that aside because we're not using it. I might put that on my other Voron 2.4 though, because my other bed's okay, but it's not great. So grab some tools, some stuff. We're going to prep our super fancy Mandala bed. So this Mandala bed comes with magnets, actual physical, I don't know if they're ceramic magnets or rare earth magnets, but they're probably rare earth magnets that are machined into the plate directly and then screwed into the plate directly, made 100% flat. This plate has been machined down to .0025. So I know this is a very flat plate. One of the biggest problems I have, if you think about it, if you're using just a standard build plate surface and you plan on putting a flex plate with PEI on it or something like that, is the fact that the magnet you're going to put on your build surface will never be flat. It just won't be. It'll never, ever, ever be as flat as your build surface. So that being said, the only real thing that comes into play with your actual build surface is, does it warp and distort when it gets heated and cooled off? And that's probably why LDO decided to make a thicker build surface than stock, which is a good thing, right? This, on the other hand, is not like that. This machine, it's using certain type of aluminum. This is the Snookum, the Super Snookum version. One more thing I want to go over on this. This is actually going to be installed on the printer using this very special kinematic kit that comes from Mandala as well, which is a 3-point install using this cross brace. So I've gone back and forth on what I want to do, because I also wanted to do a Nevermore on this printer build, but this cross brace sits right in the front of the printer where a Nevermore would go. So there are options, okay? Option one, this is the back side of the plate, by the way. Front side has the magnets, or top side. Option one is to actually mount this backwards, which would be, yeah, like that, which is actually the way that you install in a Trident printer. You can use the same build plate for a Trident printer. By the way, got this from KB-3D. Again, Kris, thank you. And if I did that, that means my support would go on the back here and I could still do my Nevermore on the front. But this looks pretty cool. I mean, it's a very nice piece of machinery, or machined aluminum, I should say. I want to show it off. I like it. So I'm not going to do a standard Nevermore on this, and I'm not 100% sure how I'm going to pull it off, but there's a Nevermore MAX that actually goes on the back of the printer, and that's going to be kind of an after the printer thing. I don't know how I'm going to print the parts for it, because they are 300 by 300, which means they don't really fit on the build surface. So if you have a larger printer, a 350 or a 400 or something like that, and you want to get a hold of me and are interested, I'll want to work out something if you want to print me my Nevermore MAX parts. All right, so we don't need to attach anything here. We need to attach them on the back. And the reason why it's important to know how we're attaching this now is because of the wiring on this plate. Try not to make a loud noise. This also, just like the one we just saw, comes with the thermistor and the heating elements already on it. Obviously, the heating element is the heating element. It does not have the thermal fuse yet. We're installing that ourselves. We're basically going to snip and tuck. But I am going to use this as the front of my printer so I can show off that. It's actually going to be like that. Yep. So that means that my wiring needs to be out the back, like that. So first things first, now that I know how I want to install this, I need to prep my surface. So this has already been cleaned, but chances are it has machine oil on it and things like that that we don't really want to have when trying to stick our heating pad to it. See some of that right there? Kind of blowing out, but yeah, you can see it. Big metal plate, kind of really reflective, huh? So take some of that off. I'm gonna spray it down again. This is 93 ISO. I'm gonna hit with a Scotch-Brite pad. Gonna do some circles. Try to get the edges. Just kind of get an even. Try to get even clean on this thing. Too much alcohol. Stay. Get rid of that paper towel, get another one. Final spray. And I don't want to touch this because I don't want any oils from my hands on it. Alcohol's evaporating so quick. Good. Put it on the desk. Clean up after myself. All right. There we go. Before I lose this. So, set that aside. So these pads have cutouts on them for the mounting screws. So basically all you want to do is make sure, you want to make sure that your screw holes aren't covered by anything. But a couple of them will be pretty close. So, yep. So on the printer, just to give you an idea what we're looking at here, let me switch over to this one. Yep. Let me bring this right down. Actually, let's just do just the desk. So, a little bit of a moire there. So on the printer, there's a couple of holes that are going to matter and a few that don't. These outside ones, these don't matter. Those two right there. These ones right here, they do matter. They're your mounting holes. This one up here, if you're doing the system I'm doing, it matters as well. If not, then these two will matter. Back here, these two threaded screw holes, one is for your thermal fuse, so that does matter. So basically I need to have room for my thermal fuse, and I just want to line things up kind of like that. Okay, once you know where you want it, you can work left to right, front to back, however you want, but basically you want to start by peeling off a small section of your adhesive panel. You try not to touch the adhesive. Wherever you touch it, it will weaken the bond. So, no touchy. And there we go. I just want to kind of get this so it's in one piece. And it's going to take off about 1/3, like so, and I'm going to fold like so. Okay. Once I have that, I'm going to come back to lining it up the way I want it. Right about like that. Okay. square it up. Before you push it down, you should have it where you want it. You can pull this back just a little bit. Okay. So once you have where you want it, you can give it a decent amount of pressure. Just like that. And then you're going to peel it back a little bit. You're going to grab your paper. And you're going to peel that. Try to keep it in one piece again. About another third. You're going to work it backwards. Like that. This is actually how you apply any vinyl to anything. And the whole purpose behind this, or the reason why we're doing it the way we are, and we're being at least slightly careful about it, is what does air do when it warms up? It expands. So any air bubble you have underneath here is going to expand and lead towards you losing lamination of your heating pad to your heated bed. So if you work this back slowly and in a straight line, I'm not going to say there's no chance, but you'll significantly improve your chances of having fewer issues. Okay. Now if you wanted to, you could kind of work in an X pattern, work from the center, pushing outwards. You want to be careful, your thermistor wires. You really shouldn't have any air bubbles underneath this. But there we go. All right. Throw that away. And I bought this time. And this is a little special. Supposedly this is 90-minute gasket maker. So cap comes off, back of the cap, plunges in, makes a little hole, cover goes on that cover, and you're going to want to use not the smallest, but a relatively small hole. Now would be a good time to put some gloves on, if I knew where my gloves were. All right, I'm gonna grab that and a razor blade. Let me see what the manual says about this, because the manual doesn't assume that this is all pre-done. So top, back, bottom, front, side to side, yep. Thermal fuse, magnetic application, clean plate isopropyl, yep. Yep, yep. Length guide, bottom, back, heater application, fairly press it to the build plate. thermal fuse. Yeah, we'll do that later. All right. So all we're really looking to do is have a bead around this, similar to the one that we saw on the LDO one, but I can pretty much guarantee it will not look as good. So this is kind of a second line of defense from having the bed heating pad delaminate off of your heating bed. And all while trying not to make too much of a mess. The good thing is if you get this on the actual heating bed more than you want, it's not a big deal. Should be good to about, well, depending on what brand you get and what one you get, about 900 degrees Fahrenheit or whatever that is in Celsius. Way more than you need. How about that? Just moving slow. There's no rush here. I mean, it is 90-minute version of the high temp silicone, but I don't think it's going to take me 90 minutes. I will say this is a little bit thicker, but I want to try it. Normally you have to leave this on for about 6 or 8 hours, maybe a little less, depending on the temperature. If you decorate a lot of cakes, you're probably gonna have a lot of fun doing this. For some reason, this edge of this wiring refuses not to get into the silicone. There we go. Set this aside, grab my razor blade, and all I'm gonna really do is kind of flatten this out a little bit. And you could use a little putty knife if you have that, or just about anything will do. Just keep in mind that you're not a machine and you're not going to go do it as nice as that LDO one that comes with the kit. But it's not a super big deal. If you look around, you'll see some pretty gnarly looking examples of silicone on a bed. Wipe off that blade. Then I come back, I'm just gonna pull off a little excess. Don't really want it on the side of my bed. And I can later come back and actually cut some of this off if I chose to. If I made a big mistake. There. Gotta clean up after myself again. Okay. I'm gonna take that. I'm gonna fold that back on that. And I'm going to set this aside. Nice and safe. Perfect. All right, well, that's it for this episode. We went and did the idlers, we got that bed all sorted out, and I'm having a great time doing this build. Hopefully you're having a fun time watching. If you are, go ahead and leave comments, hit that like button, and subscribe if you haven't, and I'll see you next time.